Hi, everyone. So, hopefully, we're hopping in on this because we have a solution, or we've been struggling with this one for a couple days and we've tried some stuff and maybe it just doesn't work out. So, let's walk through this problem. Determine the value of k such that g of x intersects f of x at exactly 1 point. So, the first area of focus for me is the problem talks about intersection. And I know that for two graphs to intersect, that would mean that I would solve the system. So what I could do within the problem is I could just label my g of x maybe as equation 1 and my f of x as equation 2. There's no need to recopy them out. And what I could now do is say, I'm going to solve that system. Now, they both start off with an f of x and a g of x, and I know that that's the same as an output, so like a y. And so I can choose to rewrite out the equations with y in their place, or I can say right now that I'm going to sub 1 into 2. Therefore, I know that my outputs have to be the same. And so for my solution then, I know that 3x plus k has to equal my 2x squared minus 5x plus 3. This is about us finding the point of intersection. Now, we do get to something that maybe causes us a little bit of a wrinkle, and this is where we may face like a little bit of indecision because we go, yeah, but normally when I when I go to solve my solution, I would now have one equation with just one variable, and I still have that k in there. And I'm going to argue to you that shouldn't be a concern right now. But I get the fact that you notice that that could be a potential snag. So if I were to say to you, well, k acts like a number, that's what we're asked to find. What if k just was a number? What would you do next? And I would hope that we would look and say, well, I'm going to try to put my x's together. I can't, so I'm going to put that into standard form. I am picturing everything going to that side because I want to have a leading coefficient that's positive. That's why I end up getting a 2x squared and a minus 8x. And now at the end, I'm going to have my 3 minus k. Everything is on one side, so it is equal to 0. So here is where we now view the snag. And we go yeah, if I knew what k was, well, then I would just solve this by factoring a formula or so on. And here's where I'm going to argue to you, let's read the problem. The problem says determine the value of k such that those two functions intersect at 1 point. And so even though I might not be able to solve the equation that I have in green, I do know something about it. I know that when I do solve that, I should only get one solution. Because that's what intersecting at 1 point means. And so here's where we have to draw back on, well, what do we know about the number of solutions? Well, I know that my discriminant is going to describe to me how many solutions I get. And if I only get one solution, then I know that my discriminant has to equal 0. So if I take a look back up in, the 2 is my A value, the negative 8 is my B value, and since k represents just a missing number, 3 minus k is my entire C value. So I'm going to take all those values and I'm going to sub those into the discriminant. So I am now calculating negative 8 squared minus 4 times 2 times 3 minus k, and I know that that discriminant has to equal 0 in this instance for my one solution. Notice what you built in red now, that's just an equation with one variable. We could now solve for k pretty quickly. I'm going to have an 8 that I'm going to expand in, so we should be okay to do that pretty quickly. That means I'm going to have my negative 8 times 3 and my negative 8 times negative k. So I get 8k. I've got a negative 40, and my k value, yikes, is negative 5. So I've now gone through, determined the value. So I just want you to notice that up at the very beginning, it starts off with a very knowledge-based action. We know that to solve a system, or to find a point of intersection, we need to solve a system. That gets the ball rolling and creates your first line in green. I'm going to argue maybe instinct, but a little bit of problem solving will get you your final line in green. And here's where drawing back on your previous information, us trying to go, okay, wait a second, the 1 point, oh, that talks about my number of solutions. There's your true problem solving. Okay, hopefully that matches up with what you've got, or at the very least, we were able to stumble through. And as I've said earlier, working on it and struggling through it is a victory in and of itself. That's how we get better at our problem solving, is through exposure to it. Okay, hopefully everything went well. Good work.